Hello dear aspirants, welcome to Epitome IAS. So in today's class, we'll be doing the PYQ analysis of climatology from the geography. So the first question would be, consider the following statements. Statement 1, the atmosphere is heated more by incoming solar radiation than by terrestrial radiation. Statement 2, carbon dioxide and other greenhouse gases in the atmosphere are good absorbers of long wave radiation. So before answering this question, let us have a quick recap about this incoming solar radiation, terrestrial radiation and the carbon dioxide and the greenhouse gases. Okay, let us say this is the surface of earth. So this is earth's surface and we have sun here. So the solar rays are directly, falling on the earth's surface. We know this. And these solar radiation, these are called as incoming solar radiation, and also they can be called as insolation. So these incoming solar radiation are of form short waves. Okay, these are of form short waves. So this thing we know. Then what happens after this incoming solar radiation or the insolation? It reaches the surface of the earth. It heats the surface of the earth. Okay. Then after a point, this earth surface, it starts radiating back those solar radiation. Okay. So the earth's surface would be radiating back the heat which was caused by the insolation. And this radiation which are radiated back from the earth, we call them as terrestrial radiation. And these terrestrial radiation, they are of the form long waves. Okay, these are also called as long waves. So the first thing which you have to remember is the incoming solar radiation are short waves and the outgoing terrestrial radiation are of long waves. Okay, this is the first thing which you have to remember. Then if you see, when the incoming solar radiation, it reaches the atmosphere of the earth, some of the solar radiation are actually reflected back to the space. Okay, and some of the solar radiation are absorbed inside the atmosphere, and some of the solar radiation are scattered. Okay, what is the difference here? Let us say reflection is nothing but, let us say the solar radiation is coming and these are the clouds. Okay, so the clouds directly reflect back the solar radiation. Okay, just like a mirror, the incoming solar radiation is directly reflected back to the space. And what is absorption? Let's say the solar radiation, it reaches the atmosphere. Some of the solar radiation are absorbed inside the atmosphere. Okay, if you see the stratosphere, it absorbs the incoming solar radiation. Then what will happen because of this absorption of the incoming solar radiation? The atmosphere, it gets heated up. Okay, first case we saw the reflection. In case of reflection, the total incoming solar radiation is reflected back. In that case, the atmosphere is not heated up, and even the incoming solar radiation, because of this reflection, it is not able to reach the surface of the earth. So because of the reflection, not the atmosphere does not get heated up, also the earth's surface does not get heated up. Okay, this solar radiation is directly reflected back to the space. But in case of absorption, what happens is these incoming solar radiation, when the atmosphere absorbs these incoming solar radiation, because of this the atmosphere gets heated up. Okay, then the other case is scattering. What is scattering? Let us say these are some dust particles which are present in the atmosphere. Now when there is an incoming solar radiation, so what this dust particle will do is it starts scattering this incoming solar radiation in all the direction. Okay, it is similar to reflection, but reflection happens when it reflects the solar radiation back to the space. But in case of scattering, by the dust particle, it happens in all the direction. Okay, some may escape to the space, but some of the radiations are reflected in every direction. So some of them will be present in the atmosphere, heating up the atmosphere, and some of the scattering of this particular, incoming solar radiation, they'll be reaching the Earth's surface, which will eventually heat up the Earth's surface. Okay, so in case of reflection, the heating up of atmosphere and the heating up of Earth's surface is nearly very low. But in case of absorption, it directly heats up the atmosphere, and it will reduce the heating up of terrestrial radiation, that is heating up of the surface of the Earth. But in case of scattering of incoming solar radiation, then what will happen? It scatters in all the direction. So some of them will heat the atmosphere and some of them will heat the surface of the Earth. So what I'm trying to say is, this incoming solar radiation, these incoming solar radiation, some of them will be reflected back and some of them will be scattered and some of them will be absorbed by the atmosphere. So apart from all these things, only few of the incoming solar radiation can actually reach the surface of the Earth directly. Okay, so this is there. If you see in the question, in the first statement, what they are saying is, the atmosphere is heated more by the incoming solar radiation than by the terrestrial radiation. So the first statement just says that the incoming solar radiation, it heats up the atmosphere more than the terrestrial radiation. So if you see here, as we already saw, the incoming solar radiation, most of the incoming solar radiation are either reflected back and absorbed by the atmosphere and scattered by the atmosphere. And if you see the terrestrial radiation, around 51 percentage of the incoming solar radiation, they'll be reaching the Earth's surface, and all these 51 percentage of the incoming solar radiation, after reaching the Earth's surface, they'll start radiating back in the form of long waves. Okay, and apart from in this terrestrial radiation, only 17 percentage of the terrestrial radiation will reach the space. It will escape the Earth's atmosphere and reach the space. Remaining 34 percentage of the terrestrial radiation, they are directly absorbed by the atmosphere. So technically, if you see, the incoming solar radiation, it heats up the atmosphere, and the outgoing terrestrial radiation, it also heats up the atmosphere, and the terrestrial radiation heats up more than the compared to the incoming radiation. Okay, so if you see the first statement, it says that the atmosphere is heated up more by the incoming solar radiation than the terrestrial radiation. This is wrong. Why? Because the terrestrial radiation heats up the atmosphere more compared to the incoming solar radiation. Okay, and if you see the second statement, the carbon dioxide and other greenhouse gases in the atmosphere are good absorbers of long wave radiation. So we see here, just like this, in the atmosphere there are some greenhouse gases. So let us do in next slide. So let us say, so this is surface of Earth and this is the solar radiation, which is incoming solar radiation. Now what happens is, in the atmosphere, let's say this is the atmosphere and we have some greenhouse gases present in the atmosphere. Example, carbon dioxide, methane. Okay, what this greenhouse gases do to this radiation? First thing is the incoming solar radiation. Okay, in case of an incoming solar radiation, these greenhouse gases act kind of transparent. Okay, they will allow the incoming solar radiation to pass through them, and it will allow the incoming solar radiation to pass through them and reach the Earth's surface. Okay, in case of an incoming solar radiation, these greenhouse gases act transparent. Okay, but let us say when there is this terrestrial radiation, that is the heat received by the Earth's surface, is radiated back from the Earth's surface in the form of long waves. Now what will happen is these greenhouse gases, they will become like a blanket in the atmosphere, and now what they will do, they will reflect back these terrestrial radiation. Now what will happen when these greenhouse gases are reflecting back these terrestrial radiation towards the Earth's surface? Because of this, the Earth's temperature is increasing. That's why we say with the increase of greenhouse gases, with the increase of carbon dioxide, methane, and etc., what will happen? It is increasing the global warming. Okay, we are talking about global warming. And why this global warming is happening in recent years? Okay, because in recent years there is an increase in the greenhouse gases. There is an increase in carbon dioxide. There is increase in methane. So because of increase in greenhouse gases, this particular phenomena is increasing. Okay, with the presence of greenhouse gases is more, it will reflect back the terrestrial radiation again to the surface of the Earth. Because of that, the Earth's surface is getting heated more compared to the previous, like 100 years before. It is compared to that, now it is getting heated up more. Okay, so if you see in the second statement, what they are saying is the carbon dioxide and the other green gases in the atmosphere are good absorbers of the long wave radiation. So yes, the terrestrial radiation are nothing but a long wave radiation. So here they are talking about a long wave radiation, that is terrestrial radiation. And just now we saw these terrestrial radiation, in case of a terrestrial radiation, the greenhouse gases along with the carbon dioxide, they will be what? They'll be absorbing, or they'll be reflecting back the terrestrial radiation towards the Earth's surface. Because of that, the Earth gets heated up. So yes, this is a correct statement. Why? Because the greenhouse gases, they start absorbing the terrestrial radiation. But in case of solar radiation, they are transparent. Okay, they let the incoming solar radiation to pass through the atmosphere. Okay, but in case of a terrestrial radiation, they'll act as a blanket over the whole Earth's atmosphere. And if you see here, first of all, let us solve this question and let us go back to this thing. So if you see, the correct answer would be statement 2 is correct, but statement 1 is wrong. So the correct answer is D. Statement 1 is incorrect, and but statement 2 is correct. So what I wanted to say here is, this is not actually a very bad thing. Why? Because in recent years, because of the increase in the amount of greenhouse gases, because of this, the Earth's temperature is getting, it's getting heated up, and because of that we are having this issue of global warming and other consequences. But this phenomenon is actually helpful for the Earth. How? Let us say, before this human made increase in the greenhouse gases, naturally what happened was, why this greenhouse gases was present in the atmosphere was, let us say this is the Earth's surface and this is the incoming solar radiation. So in normal case, what happens is these greenhouse gases are present in the atmosphere, and as usual they are transparent to the incoming solar radiation. And once these solar radiation reaches the Earth's surface, they start heating up the Earth's surface, and this heat is again radiated back by the Earth's surface in form of a terrestrial radiation. Now what happens? This terrestrial radiation, it is absorbed by the greenhouse gases, and because of this atmosphere along with the Earth's temperature, Earth's surface temperature was actually maintained. It was never too cold. Let us say this phenomena is not present, it is not there. Then what would have happened? Whole Earth would have become a ice ball. Okay, so for the maintenance of the life, the biodiversity, there is the need for some heat. So these greenhouse gases, they actually maintain the Earth's temperature. It is not too cold or it is not too hot. Okay, that's why. So if you see here, yes, this is the solar radiation. The incoming solar radiation is also called as insolation. And some are reflected back by the clouds and some are reflected back by the atmospheric gases, other atmospheric gases, and some are reflected back by the earth's surface itself. How? Let us say we have ice caps and glaciers. Okay, so these ice caps and the glaciers, they actually reflect back the incoming solar radiation. Okay, so this is how some of the incoming solar radiation are actually reflected back, and in total we call this effect as albedo effect. Okay, so what is this albedo effect? The incoming solar radiation which are reflected back either by the clouds or by the ice caps or by the glaciers. Okay, whichever the cause is, no matter, but whichever incoming solar radiation that are reflected back to the atmosphere, to the space, is called as the albedo effect. And some are actually scattered and other, some are actually absorbed by the atmosphere, and total radiation which actually reaches the earth's surface is only 51 percentage. Let us say the total incoming solar radiation is 100 percentage, only 51 percentage of the incoming solar radiation actually reaches the earth's surface. Okay, other 49 percentage are actually either reflected back or scattered or absorbed by the atmosphere, and this 51 percentage is actually heating up the earth's surface, and this heat eventually is radiated back by the earth's surface as a terrestrial radiation. And out of this 51 percentage, again if you see these clouds, they not only reflect back the incoming solar radiation, these clouds will also reflect back the terrestrial radiation towards the surface of earth. That's why in if you notice, in daytime, if there is a presence of clouds, in the atmosphere, simply notice, okay, when there is a presence of clouds in the daytime, they will actually reflect back the incoming solar radiation. So the earth's surface would be comparatively colder. So whenever there is a presence of clouds, the temperature, the room temperature will be colder. But the same case in night time, let us say there is presence of clouds in the atmosphere during the night time, then what will happen? Now these terrestrial radiations are actually happening during the night time. Okay, during the night time we don't have incoming solar radiation. In that time, night time, we have the terrestrial radiation, and when there is a presence of cloud in the night time, they are actually radiating back, the radiating back of the terrestrial radiation, these are reflected back to the earth's atmosphere. Because of that, in night time it would be very warm. Okay, you'll be having that heat feeling. Okay, when there is cloud present in the night time. Okay, so if you see here, consider that the insolation received at the top of the atmosphere is 100 percentage. No need to remember these percentages and everything. Just try to remember how things work. Okay, so let us say the incoming solar radiation is 100 percentage. Okay, then while passing through the atmosphere, some of the insolation, they get reflected back to the space, and some of them, they get scattered. I told you na, the example of a dust particle. The dust particle will actually scatter the incoming solar radiation in all the directions. Okay, then some of the incoming solar radiation are actually absorbed by the some of the gases. We have ozone in the stratosphere, so they actually absorb the incoming solar radiation. Because of that only, the stratosphere, if you see the different layers of the atmosphere, the stratosphere is very hot, okay, compared to the other layers. So because it is absorbing the incoming solar radiation, After all these reflecting back, scattering and absorption, only 51 percentage of the Earth's of the solar radiation reaches the Earth's surface. Okay, so roughly 30, if you see how much are reflected back, how much are scattered, how much are absorbed, they have given the figures. No need to remember these numbers, these figures. Just have an idea. Okay, roughly 35 units are reflected back to the space even before reaching the Earth's surface. So, how much incoming solar radiation is reflected back? That is roughly 35 percentage. Okay, some by the cloud, some by the ice caps and glaciers, and some by other atmospheric gases. So, out of this 35 percentage, 27 percentage are reflected back by the clouds. Okay, that's why during the daytime when there is presence of cloud, you will be experiencing it is somewhat colder in the Earth's surface. Okay, because around 27 percentage are directly reflected back by the clouds, and remaining 2 percentage are actually reflected back by the snows and the ice caps. Okay, though ice caps and snows present in the polar region, they are actually reflecting back the incoming solar radiation. Again, if you see during the global warming, you know what will happen? The ice caps, they'll be melting, and this is again causing the increase of Earth's temperature. How? When there is the decrease in the ice caps or the snow or the glaciers, then again what will happen? The the solar's incoming radiation, they are not getting reflected back, or the amount of getting reflected back will be decreasing. Because of that, Earth will be receiving more solar incoming solar radiation. Because of that, Earth will again get heated up. Okay, so this is also causing the global warming. Then the reflected amount of radiation is called albedo of the Earth. This is very important. This term albedo, remember this term. What is albedo? Albedo is nothing but the reflected amount of the incoming solar radiation is called albedo, and it is done by the clouds, the ice caps, the glaciers, etc. Okay, so that is the case of reflection. And if you see, the remaining 65 units are absorbed. Okay, some are absorbed by the gases, the atmosphere. So around 14 units or 14 percentage are absorbed by the atmosphere. So incoming solar radiation, only 65 percentage of the incoming solar radiation they get absorbed. Out of that 65 units, 14 units or 14 percentage would be directly absorbed by the atmosphere, and around 51 percentage are absorbed by the Earth's surface. That's what I was saying. After the absorption of the atmosphere, after the reflection done by the clouds and ice caps and everything, after the scattering effect, done by the particles which is present in the atmosphere, only 51 percentage of the solar radiation it actually reaches the Earth's surface. Okay, this 51 percentage is actually radiated back by the Earth's surface, and this is called as terrestrial radiation. Okay, then out of these 17 units are radiated to the space directly. Out of this 51 percentage, I told you only 51 percentage it actually reaches the Earth's surface. Now all these 51 percentage, the Earth will try to radiate back through terrestrial radiation, but only 17 percentage of this 51 units are actually radiated back to the space. Then what happens to that remaining 34 percentage of the terrestrial radiation? So the remaining 34 percentage are absorbed by the atmosphere. So now you can clearly see the incoming solar radiation, how much absorption is happening? Only 14 percentage of the incoming solar radiation, only 14 units are absorbed by the atmosphere. But in case of a terrestrial radiation, 34 units are absorbed by the atmosphere. That's why in the first statement, they have given that the incoming solar radiation, it heats uh, the atmosphere more than compared to the terrestrial radiation. No, that's wrong, because it's the other way. The terrestrial radiation, it heats the atmosphere more because of the absorption compared to the solar radiation. Okay, you can see here the terrestrial radiation, it's 34 units, and the incoming solar radiation is 14 units. The amount of absorption, I'm talking about the absorption done by the atmosphere. Okay, that's what is asked in the question. So technically the atmosphere is heated up more by the terrestrial radiation than by the solar radiation. Okay, then next question, consider the following statements. Statement 1, thickness of the troposphere at the equator is much greater as compared to the poles. Statement 2, at the equator, heat is transported to great heights by strong conventional currents. Okay, they are talking about the thickness of the troposphere here. Okay, so if you see here, yes, this is the layers of the atmosphere. We have troposphere here, then we have stratosphere, mesosphere, thermosphere, exosphere. You might know this. Okay, so we are talking about the troposphere. So whenever this is the layer of the troposphere, this is the Earth's surface. If you see the equator, it receives more sunlight. Okay, the incoming solar radiation is comparatively more in the region of equator compared to the poles. The equatorial region receives the direct sun rays, and the amount of insolation is also more compared to the polar region. That's why what happens is, let us say this is the equator, and this area around the equator, because it is receiving more amount of sun rays throughout the year, what will happen is it heats up the Earth's surface in that particular area. So these area of Earth's surface, they get heated up more all throughout the equatorial region. It gets heated up more compared to the polar region. Now what will happen? The heated surface, it will give rise to the strong conventional currents. So these conventional currents are rising towards the equator, in the area of equator, and because of this, it will go to like great heights. Okay, and also there is another reason, the air which is present in this particular equatorial region, okay, they are warm air. So warm air, the density, it is having a lighter density compared to the cold air. That's why they are actually present in higher heights. But in case of a polar region, it will be having this cold air, they'll be having more density. Because of high density, they'll be descending towards the surface of the earth. That's why if you compare the length of the troposphere in the Earth's equator and the length of the troposphere in the Earth's pole, the Earth's equatorial that area, the troposphere is somewhat thicker, somewhat bigger compared to the polar area. Okay. So the first statement says that thickness of the troposphere at the equator is much greater compared to the poles. Is that true? Yes. In the equatorial region, the troposphere is much, thicker. But when you compare it with the polar region, in the polar region, the troposphere is somewhat smaller compared to the equatorial region. So this statement is a correct statement. Now statement 2, at the equator, the heat is transported to great heights by strong conventional current. Yes, in the equatorial region, because of the heating of the Earth's surface in the equatorial region is much higher. Because of that, the warm air, let us say the warm air, it starts rising. You might have read the warm air will be rising and the cold air will be descending. It will be like this. So because of that, because this warm air is rising up, it will, form strong conventional currents, and because of this it will rise up and reach more height, okay, compared to the cold currents which are present in the polar region. So this statement is actually a correct statement. So what is the correct answer? Option A, both 1 and 2 are correct, and statement 2 explains statement 1. If you see here, yes, the thickness of troposphere varies with latitude. Okay, the thickness of the troposphere is not equal everywhere. It varies with the latitude. And if you see the equatorial region or the equatorial latitude, the thickness of the troposphere is much higher compared to the polar latitude. And this variation is due to the differences in the temperature. In the equatorial region, it is going to be much more temperature. The temperature is going to be high compared to the polar regions. And because of this, there is a difference in the density of the air. The warm air which is present in the equatorial region, they are less denser compared to the cold air which are present in the polar region. They are more denser compared to the equatorial air. Okay, so the warm air with less density, it causes the troposphere to expand. Okay, and that's why the troposphere is thicker in equator. But and the equator, at the equator, the intense solar heating cause strong conventional currents. Again, this is also another reason. There are two reasons. One is because of the warm air, it is having less density. It the troposphere expands. Okay, that is one reason. Second reason is because of intense heating is happening in the equatorial region. Because of that, strong conventional currents are formed. Okay, strong conventional currents are formed, and they're very strong that they are capable of reaching more height. Okay, so that's why these are the two reasons, and these current transport the heat to great heights, contributing to the greater thickness of the troposphere. Next question, with reference to water vapor, which of the following statements are correct? Statement 1, it is a gas the amount of which decreases with altitude. Statement 2, its percentage is maximum at the poles. So if you see here, they are talking about water vapor, just like carbon dioxide or other constituents of the earth. Water vapor is also one of the major it is an important constituent of the atmosphere. Okay, so in case of a water vapor, it is actually gaseous form of water. So after getting evaporated, the water which is present in oceans and streams, these water, they get evaporated and they'll be forming water vapor and they'll be present in the atmosphere. You all know that. So the gaseous form of a water is called a water vapor, and what they are saying is it is a gas. Yes, this is a gas. Water vapor is a gas. It is a gaseous form of water. Okay, this is there. Then the amount of which decreases with altitude. What they are saying is, let us say this is the surface of earth, and they are saying that with increasing altitude means height, altitude is nothing but height, the water vapor decreases. They are saying in the you know near the surface of the earth, the water vapor are much higher compared to the you know greater height of the earth's atmosphere. If you see, this is true. The water vapor majorly is presented very near to the earth's surface in the atmosphere, and if you are moving, increasing the height, the amount of water vapor will be decreasing. That is one point. This statement is a correct statement. Its percentage is maximum at the poles. So now if you see here, let us say this is the earth. Okay, in the equatorial region, as we already saw, it gets maximum solar radiation, incoming solar radiation. Okay, because of that, if the equatorial region is getting maximum solar radiation, because of that, this particular region, the equatorial region, is very warmer compared to the polar region, because the polar region, they are getting very less number of incoming solar radiations. These poles are comparatively colder, you know So what they're saying is the percentage of water vapor in the polar region is maximum, they are saying. So in the equatorial region, because of a maximum incoming solar radiation, the evaporation will be happening more. Okay, when there is more heat, obviously more evaporation will be happening. When more evaporation is happening, more number of water vapor will be present in that particular location, in that particular area. So technically in the equatorial region, the water vapor, content of water vapor will be maximum. And in polar region, we know that because of very low incoming solar radiation, because of that, this particular polar region, they'll be having very less evaporation happening there. And because of the less evaporation, you can say that the presence of water vapor will be very low in the polar region. So this statement is actually a wrong statement. Okay, so what is the correct answer? The correct answer is only one. Option A is the correct answer. So see here, water vapor, yes, it is a gaseous form of water vapor. It is a gas, okay. Then it is present in the atmosphere and it is called as water vapor. The amount of water vapor decreases with the increase in altitude. So whenever you are moving towards, you're moving towards the height, increasing the height, then the water vapor present in the atmosphere will be decreasing with increasing in height. It also decreases from the equator towards the poles. Let us say this is Earth and this is equator, this is pole. So whenever you are moving from the equator to the poles, it will actually decrease. So the maximum is in the equatorial region and the minimum would be in the polar region. Apart from the polar region, wherever you have these, glaciers, ice caps, or let us say we have deserts, both cold desert and warm desert. In both the cases, the water vapor will be very less, okay, because there is if there is a presence of water body like oceans or other streams, then only evaporation can take place. Let us take the very heat desert, hot desert. In that case, we have strong, very high solar radiation, but there is no presence of water, there is no presence of streams or oceans. That's why in that case also the presence of water vapor in the atmosphere is very low in case of deserts, apart from the ice caps and the polar region. So it is maximum amount in the atmosphere could be 4%. So wherever the equatorial region or the warmer regions where there is presence of stream and ocean, everything, here the maximum amount of water vapor that can be present in the atmosphere would be 4%. And if you see in the polar regions, it can be less than 1% also. The presence of water vapor in the atmosphere is less than 1% in the polar areas, and in the warmer areas it would be 4%. So the water vapor absorbs the part of incoming solar radiation, that is the insolation from the sun, and preserves the earth's radiated heat. It thus acts like a blanket, allowing the earth neither to become too cold nor to become too hot. So the water vapor also contributes to the stability and the instability in the air. So as I already told you, the clouds, similar, the water vapor which is present in the atmosphere, what they do, in case of any incoming solar radiation, it will absorb the heat. Because of that, it will help the earth not to get heated up more. And in case of a terrestrial radiation which is radiated back by the earth's surface, it again absorbs the terrestrial radiation. What will happen? Because of that, this earth's surface is maintained, okay, it is not becoming too warm or too cold. So these water vapor are actually maintaining the earth's surface, okay.